Okay, just to finish up number, oh, I said number 2, but it's really number what, 19? Sorry. 19. Okay, so I had, just as the other video ended, I said you could check it on number 1, on the number 1 kid. So pulling forward on the number 1 kid, we found it was 21.23 newtons. Pulling backward on this kid, we found was the 15.4 newtons. If you do sum of the forces is equal to M1A, it'll be that F minus the F12 has to equal M1A. So it'll be 21.23, and the 3's repeating there, minus 15.54 will equal 25 kilograms times, I forget, 0.23 repeating meters per second squared. And so, did I not save it? I didn't. Shoot. 3.5 divided by 15, there we go, times 25. So this side is 5.8, 3 with the 3 repeating, and this side is also going to be 5.8 with the 3 repeating. Check. Okay, so that's on page 182. Now I also asked you to do the very last question on the second sheet, forces sheet that you had. We had done all of them except for the very last one, which is a skating instructor pulling 3 small children. Okay, so here are my 3 small children again. Their masses in order are 20 is the lead dude, 15 is the middle dude, and 10 is the last dude. And they're being pulled this way by some force. The instructor is pulling with a force of 135 newtons. Okay, assume no friction. What is the acceleration? So if you want to find the acceleration and you're not given VF, VI, that kind of stuff, but you're given the overall force, then look at the whole system. And it'll be the 10 kilogram plus the 15 kilogram plus the 20 kilogram, which is 45 kilograms. And this F going forward at 135 newtons, so that when you do the sum of the forces, it's only that F because it says ignore friction. So it'll be F equals M total A. A then will equal that F divided by M total. So 135 newtons divided by 45 kilograms. A should be equal to 3 meters per second squared. Then it says, what is the tension in their arms? So you need to find the FT1 here and the FT2 here, okay? And always you start with the end one. So on number 3, the 10 kilogram dude. Number 2, number 1. So on number 3, no friction, so pulling forward is just FT2. And this is 10 kilograms. Do the sum of the forces should equal M2A. It's just going to be FT2 is equal to M2A. M2 is 10 kilograms. A is 3 meters per second squared. So FT2 should be equal to 30 newtons. Then go to number 2. So on number 2. Number 2 is 15 kilograms. Pulling backward on 2 is the force we just found, 30 newtons. Pulling forward on 2 is kid number 1, FT1. You're going to do the sum of the forces will equal M2A. That should have been a 3. Sorry. I was on number 3 and I was saying mass 2. And still direction of motion is positive, so it'll be FT1 minus FT2 will equal M2A. This time you're looking for FT1, so it'll be equal to M2A plus FT2. M2 is 15 kilograms, A is 3 meters per second squared, and FT2 was 30 newtons. So that's 45 plus 30, FT1 is 75 newtons. And then if you wanted to do your check, you would do it on the front kit, on the 20 kilogram kit. Pulling forward is the force we were told, 135 newtons. Pulling backward is the force we just found, FT1, 75 newtons. Forward is still positive. Do the sum of the forces is equal to M1A, and it will be F minus FT1 should equal M1A. So 135 newtons minus 75 newtons should equal 20 kilograms times 3 meters per second squared. 25 and 35 is 60 newtons, and 3 times 20 is 60 newtons. Check, all is well. Okay, the one last question I asked you to do was example number 4. This one has friction in it. So we did example number 3 and an earlier video that had friction. So it's now time to do example 4, which has friction. So a skidoo is pulling a chain of 3 sleds behind itself by applying a force of 500 newtons. So 3 sleds. 1, 2, 3. And it's applying a force, it says, of 500 newtons. In order from the front sled, this one's 40 kilograms, 50 kilograms, and 60 kilograms. And this is sled number 1, number 2, number 3. And it wants to know what is the frictional force, it tells us, the acceleration is 1.371 meters per second squared. And it wants to know what is the frictional force acting on the whole system. So for part A, we have to start with the whole system. So on system. Okay, so here's my whole system. If I add these up, it's 150 kilograms, my whole system. Pulling forward is the force of 500 newtons, like they told us. We're looking for the force backward. If we do sum of the forces is equal to M total A, it will be F minus friction is equal to M total A. And we're looking for friction. So bring this over, bring this over. So friction is equal to F minus M total times A. So friction is equal to 500 newtons minus 150 kilograms times that 1.371 meters per second squared. And when you do this, you get a force of friction to be 294.35 newtons. That's part A. Part B wants to know what is the coefficient of friction. So if we want the coefficient of friction, then we need to do FFR is equal to mu Fn. So mu is going to be equal to the friction we just found divided by Fn. Now what's Fn? Well, there's an Fg going down and an Fn going up. If we did the sum of the forces in the y direction on the whole system, it would be Fn minus Fg equals 0. So Fn is just going to equal Fg. So here this is going to be friction divided by M total times G. So mu is going to equal 294.35 newtons divided by 150 kilograms times 9.81 meters per second squared. So mu is going to equal 0.200034. Part B. Part C is the tricky part, and it's where we're going to run out of time, of course. C wants the tension in the rope. So start on each spot. So start on number 3. Okay, it's 60 kilograms. You need to find the FT going forward, but you also, and that'll be from 2, you also need to find the friction on 3 acting backward. This will be FG3, this will be